Welcome, this is Professor Ridge and today's lesson 9.4, series and their notations. Our first learning objective, use summation notation. Summation notation, the sum of the first n terms of a series can be expressed in summation notation as follows. So we use the Greek letter sigma here, and on the bottom this is k equals 1. That's what we call the lower limit of summation. Okay, so that's where we start. And then n is the upper limit of summation. That's where we stop. So we got start, stop. That's kind of the way I think of it. Start, that's your initial value. And that's your terminal value. Stop. Okay, so we're going to start at 1, and when you index, you always increase by 1, right? Because like a series, right? 1, 2, 3, so on. Okay, this notation tells us to find the sum of a sub k from k is 1 to k is n. K is our index variable, right? K is called the index of summation or index variable, and that's what we're going to replace. So this is basically, so the summation of k, and usually for the index variable you can use ij or k. It's typical. You can use any letter. It doesn't have to even be ij or k. So let's say we went 1 to 5 of a sub 1. So that'd be a sub k, sorry. So that would be a sub 1, and then you index it, and you go to 2, and then you just keep going up by 1 until you get to the terminal, the upper limit of summation, using the book's terms here. So we're going to keep indexing it until we get to 5. And you're going to add up all these terms. Now sometimes we can use this as like a variable. So let's say I'm going to use I this time. I from 1 to 4, and let's say I'm going to do 2i. So I'm going to plug in 1 and then 2, and I'm going to keep doing that, indexing it until I get to the top number, which is 4. So I stop at 4. So this will be 2 plus 4 plus 6 plus 8, which will get me 20. So that is the sum of the first 4 terms of that sequence. And that's what we call a series. So a series is just the sum of the terms of a sequence. Okay, let's look at example 1 here. Evaluate the sum of k squared from k equals 3 to 7. Okay, so we're going to start at 3, end at 7. So k is 3, and then squared, plus, and then index it. So you go to 4 squared, 5 squared, and we keep indexing it. So just keep adding 1, so that'd be 6 squared, and then we stop at the top one, which is 7. And then we work out each term, so that'll be 9 plus 16 plus 25 plus 36 plus 49. And then we punch it in our calculator. Let's see, 25, 50, 86. So what's 86? Plus 49. 12, 13, 135. Okay, next learning objective. Use the formula for the sum of the first n terms of arithmetic sequence. Okay, the formula for the sum of the first n terms of an arithmetic series. So again, a series is just the sum of the terms of a sequence. So an arithmetic series is the sum of the terms of an arithmetic sequence. The formula for the sum of the first n terms of arithmetic sequence is given by this equation here. So that this notation S sub n, that's basically the sum of the first n terms of the sequence, right? So that's series. So S sub n is the sum of the first n terms of the sequence. So the shortcut is given by you take the first term and the last term and add those together, multiply it by n, and divide it by 2. So for instance, if I wanted to take, let's say I wanted to do this arithmetic sequence and add up all the terms. Let's just do 5. Okay. So if you take the first term plus the last term, that's 6. And then you can see 2 plus 4 is 6. And then you got 3. Using that shortcut formula, S sub 5 would be 5 divided by 2. A sub 1 is 1. A sub 5 is 5. 5 times 6 divided by 2. 30 divided by 2 is 15, which is, again, 6. 6 is 12, plus 3 is 15. So you get the same answer. Example 2, finding the first n terms of an arithmetic sequence or series. Find the sum of each arithmetic series. So they told us they're arithmetic already, so we know we don't have to check that. We just have to use the formula. So let's see, there's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to say S sub 10 is 10 times A sub 1 plus A sub 10 over 2. So that will get us 10 times 5 plus 32 over 2, which would be 10 divided by 2 is 5 times 37. So let's see, that'd be 150, 185. All right, let's try B. So S sub 1, 2, 3. Okay, now here they don't list them all, so we have to figure out, we have to do some extra work to figure out how many terms there are. So if you recall from the previous section, when we did, well, 2 sections ago actually, A sub n is negative 50. So let's see, we're subtracting 5, subtracting 5. So A sub 1 is 20. D is negative 5. And if we use the formula for arithmetic sequence, A sub n is equal to, what was it? A sub 1 plus D times n minus 1. So we want to figure out n, and we know A sub n is negative 50. A sub 1 is 20. And then n minus 5, and we just solve this equation. So we get 20 minus 5n plus 5. So that's 25. And then subtract 25, you're going to get 75. Okay. Hopefully that wasn't too much skipping steps there. So 20 plus 5 is 25. And then I just subtracted 25 from both sides. And then divided by negative 5. So n is 15. Okay, so now we know it's 15. So our series is going to be 15 divided by 2 times A sub 1, which is 20, plus A sub 2, A sub n, which is negative 50. So that's going to get us 15 times negative 30 divided by 2, which is negative 225. All right, so that's B. And then C. So now, now here's the thing. If you did the summation from 1 to 2, that's going to give you 2 terms. So if you subtract this, that's not going to be n. You got the number of terms. You got to add 1 to it. So if we're going to 12, oh, n's still going to be 12. Okay, never mind. I was thinking about something different. Okay, so that'll be fine. So what we're going to do is figure out, this is going to be 3 times 1 minus 8 plus, so this is our first term, and we don't care about all the terms in between. We want to know the last term, the 12th term. 3 times 12 minus 8. So that's going to be, so the first term will be 3 minus 5 is negative 5 plus dot dot dot, and then the last term will be 36 minus 8. 36 minus 8 is 28. Okay, so our S sub n, which in this case is 12. So again, ignore what I was talking about up here. I was basically going to show you if you started offset, but anyway, just ignore that. S sub 12 would be 12 divided by 2, the first term, which is negative 5, the last term is 28. So that's 23 times 12 divided by 2, or 23 times 6. 23 times 6 is, should be able to, let's see, 23 times 6. 23 times 6, 12, 13. So we get 138. Okay, on to the next learning objective. Use the formula for the sum of the first n terms of a geometric series. Okay, so here's the formula for a geometric series. A geometric series, sum of the terms of geometric sequence. The formula for the sum of the first n terms of geometric sequence is represented as S sub n equals A sub 1, so the first term, times parentheses 1 minus r to the n, all over 1 minus r, provided r is not 1. Okay, so let's try A here. Use the formula to find the indicated partial sum of the geometric sequence. We want the sum of the first 11 terms. So we got A sub 1 is 8. 1 minus r. Now, okay, so r, remember, r is equal to, you take the previous term, or any term divided by the previous term, the one immediately preceding it. So we got negative 4 divided by 8, so that's negative 1/2. We're going to the 11. Now you got to be careful with the signs here. We got to take negative 11. We got to take negative 1/2 to the 11th power, which will give us a negative number, and then 1 minus a minus will become plus. But if this was an even power, That'll make this positive, and then it'd be 1 minus whatever that number is. So it alternates. And then 1 minus a minus 1/2. So this will be 1 plus 1 over 2048. 1 minus a minus 1/2 is the same thing as 1 plus 1/2, which is the same thing as 3/2. So let's see here. So this will be equal to 2048 plus 1 would be 2049 over 2048. And we got times the 8. Divided by 3/2 is the same thing as multiplying by 2/3. And I can just punch all that. I could have just punched this whole thing in Desmos, scientific calculator, got an answer. Either way. All right. I like to start with the divided first, and then it gives me my template for the top number. So 8 times parenthesis 1 minus parenthesis r, which is negative 1/2. So negative 1 divided by 2, close parenthesis, and then power, in this case 11, and then close parenthesis. Now the bottom, 1 minus a minus 1/2. So minus 1 divided by 2. And you can see that's 5.33 if I want a fraction, which that's what I was going to do over here. Just reduce it. So you would end up with the same fraction. Okay, so either one, 683 over 128. Or if you want to do the decimal, .33, well, you would have to round it, 5.33, so 3/8, so 3/4. Okay, now B. So for B, let's do this one. So for B, let's see, R is 2. We're going to start with 1 to 6. So we're doing, let's see, R, so S sub 6. The first term would be, if you put in 1, so 3 times 2 would be 6. 1 minus R is the 2. And then 2 to the 6 over 1 minus 2. So we get 6, 1 minus, let's see, 2, 4, 8, 16, 32, 64. 1 minus 2 is minus 1. So that'd be 6 times negative 63 over negative 1. So the negatives cancel, and we get 6 times 63, which will be 360, 378. Example 5, solving an application problem with geometric series. At a new job, an employee's starting salary is $26,750. He receives a 1.6% annual raise. For his total find his total earnings at the end of 5 years. Okay, so we want the total, so that's the series for 5 years. So his initial amount was 20. Here, let's write the formula. So a sub 1, 1 minus r to the n, which in this case is 5, over 1 minus r. So a sub 1 is 26,750. R is, remember, R is you got to add 1 to it if, because of geometric sequence. So it's 1 plus 0.016. So 1.016 to the 5th power all over 1 minus 1.016. And then we're going to punch that in our calculator. Let's see here. I was just seeing what his last year's salary was there. So let's see. The initial amount was 26,750. Oops. Times. Oh, I need my fraction bar here. Okay, so it's going to be 26,750 times parenthesis 1 minus r, 1.016 to the power 5 years, parenthesis, bottom, and then it's 1 minus r. R is 1.016. And then, so our total salary for the 5 years would be $138,099. Oops. Okay, so that will be $138,099.03. Okay, the next learning objective, use the formula for the sum of an infinite geometric series. Okay, so if we have an infinite series is the sum of terms of an infinite sequence. An example of an infinite series is 2 plus 4 plus 6 plus 8 plus ... right, forever. So if we write in summation notation, you can see the upper limit is infinity. That's the infinity symbol. So you just keep adding the next term onto infinity. So the upper limit of summation is infinity. Because the terms are not tending to 0, the sum of the series increases without bounds. So this is an important concept. So each subsequent term gets bigger and bigger and bigger, and you just keep adding it and adding it. And we say that that series diverges. Okay, so if the sum just keeps growing without bound, it's what we say that series diverges. Okay, determine whether the sum of infinite geometric series is defined. So if the terms of a geometric sequence approaches 0, the sum of the infinite geometric series can be defined. The terms of this series approach 0. So notice if the common ratio is, we'll talk about this in a second, between -1 and 1, what happens is each subsequent term is going to approach 0. It's going to get closer to 0. So in this case, r is 0.2. So you can see it just gets smaller and smaller and smaller, closer and closer to 0. So as n gets very large, as we keep adding the next term, the values of r to the n get very small and approach 0. So each successive term affects the sum less than the preceding term. So as you add terms that are getting closer to 0, the sum of the terms approaches a finite value. So if you're adding almost nothing, it pretty much leaves the sum alone. It's not going to grow very much. So there's a limit to how much it can grow, is what we say. So the terms of an infinite geometric series with r between -1 and 1 approach 0. The sum of a geometric series is defined when r is between -1 and 1. Okay? Or another way to say that same thing, we can say that absolute value of r is less than 1. So this is the same statement. So in summary, basically, if you want to determine if the sum of infinite geometric series is defined, then r has to be between -1 and 1. Okay, so the sum of infinite series is defined if the series is geometric, so it has to be geometric, and the common ratio has to be between -1 and 1. Okay, so there's two parts. We got to check that it's geometric. So determine whether the sum of each infinite series is defined. So we have to decide, is the common ratio, is there a common ratio? So 8 divided by 12, which is divided by 4, so be 2/3. And then we got to do 4 divided by 8, which is 1/2. So not geometric. Okay, B. So we don't have to check what R if there's no R, if it's not geometric. So 1/2 divided by 3/4. Well, remember you flip that over. 1/2 times 4/3. So that'd be 4. Let's see, I can reduce. So I get 2/3. And then 1/3 divided by 1/2. So yes, that one's geometric. R is equal to 2/3, which is between -1 and 1. So yes, it's defined. Series is defined. Okay, so you can get you can add it up and get a sum, which we're going to go over in a minute. All right, then the next one, C. Let's see. You can see that every subsequent term you're going to multiply by 1/3. So yes, that's geometric. R is equal to 1/3, and it's defined because, again, it's between -1 and 1. Okay, and D, let's see. That one is not geometric because if it's actually arithmetic, because if you look at it, it is so if you put in 1, you get 5, put in 2, you get 10, put in 3, you get 15, and you can see the common ratio it wouldn't have a common ratio. So 10 divided by 5 is 2, 15 divided by 5 is 1.5. So this is not geometric. So not geometric. Okay, so just B and C are geometric, and both of those, the series is defined because R is between -1 and 1. Okay, so here's the formula to find the sum of an infinite geometric series, and remember, it's only defined if R is between -1 and 1. And it's given by the series is equal to the first term, a sub 1, divided by 1 minus r. Okay, so it's pretty simple. Okay, find the sum if it exists for the following: 10 plus 9 plus 8 plus 7 to infinity. This one does not, this is not geometric, right? Because there's not a common ratio, so we don't worry about it. This one, let's see, if we divide, let me get a calculator. Okay, so we're going to divide 99.44 divided by 248.6, which I did up here. You see I get 0.4. And remember, you take the latter term divided by the preceding one, the one that's immediately before it. So 39.776 divided by 99.44, which you see here I got 0.4. So they have a common ratio of 0.4. So that's geometric. The common ratio is between -1 and 1, so it exists. So our series, infinite series, is going to be the first term. It's the first term divided by 1 minus r, which we just established as 0.4. Okay, let me get that calculator back. So let's see, we're going to do 248.6 divided by 1 minus 0.4. So it'd be, now if you're using a regular calculator, you make sure you put parentheses around that. So 414.33. 3333. Okay, so which equals 414.33, which is 1/3. Okay, so C, you can see it's geometric again. So our initial term, if we put in 1, this would be 0. So 4374 is our initial term. So this one's geometric, with r being -1/3. So S will be, our initial term is 4374, 1 minus 1/3, minus a minus 1/3, which becomes 1 plus 1/3, which is 4/3, because 3/3 plus 1/3 be 4/3. So that's, and then you flip it over, so it will be, let's see, what's my number here? 4374. 4374 divided by 4/3. Let's see if it takes it this way. Not 4/3. Yeah, 4/3. 4/3. So 3280.5. 3280.5. 3280.5. Okay, and then D, it's geometric, but R will be 4/3. R equals 4/3, which is not between, so this is not defined. The series is not defined. Right? It grows without bound. Okay, so the infinite series is not defined. Since R is greater than 1. Okay, find an equivalent fraction for the repeating decimal 0.33, or 3 with the bar. So it's 0.33333. 3, so on. You can think of it as this way. It's 0.3 plus 0.03 plus, and just keep adding the next digit. So we can think of this as a geometric series where R, so if you divide this, R is equal to, so this is a geometric series. Where R is equal to, now if you divide 3/100 divided by 3/10, you're going to get 1/10. Okay, so that's or 0.01, 0.1, either way, right? 1/10 or 0.1. So the sum of this geometric series would be our initial value, 0.3, 1 minus 0.01, or 0.1, sorry, which is 0.3. Well, we want to do it as a fraction because we want to write it as a fraction. So let's change this to 1/10, which equals 0.3 over 1 minus 10 would be 9/10. And then 0.3 is the same thing as 3/10. 3/10, and then 9/10. If we're dividing by 9/10, we're multiplying by 10/9. And then you can reduce this fraction, 3/9. You divide 3 out of both of those, so you get 1/3. And our last objective, solve annuity problems. Solving annuity problems. So here's the technique. How to, given an initial deposit and an interest rate, find the value of an annuity. So determine the initial value, the initial deposit, determine N, the number of deposits, determine R. So remember, for R, you just divide the annual interest rate by the number of times per year that interest is compounded, and add 1 to this amount. Okay? Substitute the values A1, R, and N into the formula for the sum of the first n terms of geometric series given here. And then simplify, define S sub n. That's the value of the annuity after n deposits. So a deposit of $100 placed into a college fund at the beginning of every month for 10 years. The fund earns 9% interest, compounded monthly, and paid at the end of the month. How much is the account right after the last deposit? Okay, so our first A sub 1 is the 100. R, or N is, we're doing it monthly for 10 years, so there's 12 months for 10 years, so that's 120. And then find R. R is, we're going to take the interest rate by the number of times per year, so that's 12. So R is going to be 1 plus, remember we got to add 1 to the R to find R. The interest rate, which is 0.09 divided by 12. Okay, so whatever that is, 1.0075. Okay, now we're going to substitute all those values into the series. So I'm going to write it up here. So S of 120 is equal to 100, 1 minus 1.0075 to the 120, over 1 minus r. 1 minus 1.0075. Okay, let's get Desmos. Okay, so 100 times parenthesis 1 minus 1.0075, oops, to the power 120, and then on the bottom 1 minus 1.0075, and it looks like we get 19,351 and 43 cents. 19,351 and 43 cents. All right, and I believe that is the end of our section. So again, you want to practice, go to the end of the section and do all the section exercises, or at least all the odds. If you have time, do some of the evens. All right, and I will see you next time. Have a great day.